Basalt Engineering, BasTech rebar that's stronger, lighter, and rust-proof. Basalt fiber reinforced rebars are transforming civil engineering by combining high performance with eco-friendliness. Derived from naturally occurring volcanic rock, basalt offers remarkable mechanical and chemical stability. BasTech's basalt rebar leverages these properties to outpace traditional steel reinforcement, promising longer lifespans, reduced maintenance costs, and lighter structures. Basalt fiber production begins with melting crushed basalt rock at around 1,400 degrees Celsius. The molten material is extruded through fine nozzles to form continuous filaments, which are then sized and bundled into rovings. These rovings are coated with epoxy or polyurethane resin systems to ensure excellent adhesion within concrete matrices and to protect the fibers from alkaline environments. Basalt rebar distinguishes itself through a combination of properties that surpass those of conventional steel. Tensile strength: BasTech basalt rebar exhibits tensile strengths in excess of 1000 MPa, compared with around 500 to 700 MPa for typical carbon steel rebars. Density: with a density of approximately 2.7 g/cm superscript 3, basalt rebar is about 30 to 40% lighter than steel, enabling easier handling and reduced dead loads. Elastic modulus: the elastic modulus of basalt fiber, 50 to 90 GPa, aligns well with the stiffness requirements of reinforced concrete, minimizing deflection under load. Steel reinforcements suffer from corrosion when chlorides or carbonation penetrate concrete cover, leading to concrete spalling and structural degradation. In contrast, basalt fibers are chemically inert in alkaline environments and impervious to chloride attack. BasTech's proprietary sizing further enhances durability, ensuring the rebar remains rust-proof throughout the structure's service life. Beyond mechanical performance, basalt rebar offers additional advantages. Thermal stability: basalt fibers retain strength at elevated temperatures, up to 700 degrees Celsius, providing better fire resistance than steel. Electromagnetic neutrality: being non-metallic, basalt rebar does not interfere with electromagnetic signals. This property is critical for structures requiring radar transparency or for minimizing interference in sensitive installations. BasTech basalt rebar has been successfully deployed in a range of projects. Marine structures: bridge decks and piers exposed to saltwater environments have benefited from long-term durability without cathodic protection. Infrastructure rehabilitation: highway overlays and repair patches in freeze-thaw climates resist cracking and delamination far better than steel-reinforced overlays. Water treatment facilities: tanks and piping exposed to aggressive chemicals maintain integrity, reducing downtime and maintenance costs. By replacing steel with basalt rebar, engineers achieve carbon footprint reduction: basalt fiber production requires lower energy input than steel making, cutting greenhouse gas emissions. Life cycle cost savings: elimination of corrosion-related repairs and longer service life translate into substantial cost avoidance over decades. Resource sustainability: basalt rock is abundant and non-toxic, supporting circular economy initiatives. As global infrastructure demands accelerate, the advantages of basalt rebar position it as a leading alternative to steel. Ongoing research focuses on hybrid composites, combining basalt with carbon or glass fibers to fine-tune mechanical properties. Additionally, 3D printed concrete elements reinforced with basalt fiber open new architectural and structural possibilities. BasTech's basalt fiber rebar redefines reinforcement by delivering unmatched strength, significant weight savings, and inherent corrosion immunity. From coastal bridges to industrial plants, this innovation enhances structural performance while reducing long-term maintenance costs and environmental impact. As the construction industry embraces sustainable materials, basalt engineering stands at the forefront of a resilient, lighter, and rust-proof future.